Hello and welcome to this tutorial on buffer and overlay analysis. In this tutorial, we're going to talk about what those two functions are and how they are operated in SuperMap iDesktop. So let's get started. So this is the overview of this tutorial. In buffer analysis, we're going to create a buffer for selections and datasets, and we're going to create a multiple ring buffer. In overlay analysis, we're going to talk about all of these listed operations, such as clip, erase, intersect, union, identity, XOR, and update, but we're going to operate only some of these so that the rest are left for you to practice on. So let's talk about buffer analysis for a bit. So what is a buffer? So a buffer is the extension space created around a given object, such as a point, a line, or a polygon. Now, what is buffer analysis? A buffer analysis is a process of forming polygon entities with certain extents around a group or a single type of map features, such as points, lines, or regions, according to a specified distance condition. It is an information analysis technique for extending 2D spatial extents of geographical objects in data. Buffer analysis can be used to create buffers, single buffers, or multi-buffers. Now, some examples include creating buffer for the selected road line and then using the buffer result to query residential buildings that intersect with the buffer region so that we can find out which buildings will need to be altered or removed altogether. Second, to get affected regions around some dangerous spots to answer some public safety concerns. And finally, also for public safety, what neighborhoods will be affected by floods? So we are here in SuperMap iDesktop and we have our buffer analysis data source open, and we have opened up two data sets here, the building polygon dataset and the road line dataset. So we're going to go ahead and we're going to make a selection of this road that we saw in the presentation as well, and we're going to go under spatial analysis, and under buffer zone we're going to say buffer zone again. Now here we want a union buffer, and because we made a selection, the selected objects only checkbox has been checked by default. We're going to keep the semicircle segments at 100, and we're going to change the buffer type to flat. Both left and right will be checked. We're going to change the radius to 8 and 8 for this example, and we're going to say OK. So we have our buffer there. Now we need to run a spatial query in order to find out which buildings is this buffer zone intersecting. So we're going to select our buffer zone here. Under spatial analysis again, and spatial query this time, 2D spatial query, we're going to select our building polygon dataset, and under spatial query condition, we're going to say intersect region. So which region of the buffer zone is interacting with which region of the buildings dataset. So there we go. We're going to want to save this result, and we're going to say query. So there we have it. The buildings that the buffer zone intersects with have been highlighted, and we can view them separately from our saved spatial query. So these are the buildings that will need to be demolished or altered in order to make way for the new road project. So now we're going to do the other instance. We're going to use a data set to create a buffer zone. Now what's going to happen here is that our selected objects only checkbox is going to be grayed out, and there is going to be some difference in here. So let's go ahead and demonstrate that. So we're going to close this data set here and the attributes as well. And we're going to want to remove this layer as well. We're going to delete this right then. So this time we are not going to make any selections, and we are going to go under spatial analysis and buffer zone again. So we have this open here, and so this time we are going to have a comparison between round and flat. So we have selected our road layer, and we're going to go under buffer zone and buffer zone again, and we will demonstrate the difference between round and flat buffer type. So first off, we're going to select round. We have our road dataset selected. We're going to demonstrate flat first, and here we have our road dataset selected. The selected objects only checkbox has been grayed out. We are not going to check the union buffer under output this time, and we're going to select field this time, and we're going to say left radius and right radius. So we're going to say okay. So this is how it looks like with the flat one, and we're going to make that layer invisible and go into our root layer again, buffer zone again. Let's make it round this time. So we're going to make the semicircle segments 10, and we're going to change the radius to 3 and 3, and we're going to say okay. So there we have it. We can demonstrate the difference like this here. You can see how they're different. So there we have it. Now that was an example of a single buffer zone. We can also create multi-buffer zones. Now, a multi-buffer zone is created, for example, for a railway line to analyze different levels of noise that affect nearby residential areas with noise pollution. So these can be created for point, line, or regional data sets, and it can have several buffer radiuses, as you can see over here. So we can say right here, the noise is going to be the highest, then it goes lower, lower, and lower in each buffer zone. So this can have numerous applications. So we're going to do this exercise now. We're going to create gradient effects for a country boundary, which is China, and we're going to make a unique map for the buffer result data set. So let's revise this. Step 1, SQL query with ID 10, create a multi-buffer, and then render the analysis result by creating a thematic map. So let's go ahead and do this. So for this demonstration, we are going to be using our boundary data set here. And so first of all, we're going to launch a SQL query, and we're going to clear this out, all of this. So here we're going to select all, and we're going to say ID equals 10. And we're going to highlight it on the map, and we're going to save the results as well. So let's say okay. So here's our query result where all the boundaries of Greater China have been selected. And the next step is to go under spatial analysis, buffer zone, multi-buffer zone. We're going to make it flat, and we're going to keep it at left radius, and these 3 options will be checked as default. And we're going to create 3 radiuses. We're going to say insert and add the ending value first, which is going to be 60,000. We say insert again, second value 30,000, insert again, and the last value 10,000. And I'm going to say okay. So there we have it. Our multi-buffer has been created, and we can see there are 3 buffer zones, 1, 2, and 3, all around the boundary. So now in order to make this more visible, we're going to create a thematic map, and for that we're going to say right click on our polygon here. We're going to say create thematic map. It's going to be a unique values map, and we're going to say okay. So there we have our thematic map created so that we can see our buffer zones more clearly. So let's move on to overlay analysis. Starting off with what is overlay? Now overlay is the operation of comparing variables between 2 data sets. So what is overlay analysis? Overlay analysis is one of the basic GIS spatial operations. It is a process of generating new data through a set of operations on vector datasets. iDesktop provides overlay analysis functions for point, line, and region datasets. Common overlay analysis functions include clip, union, erase, intersect, identity, symmetrical difference, and update. Now there can be numerous applications for overlay analysis, but some of them are as follows. We could find out the lake distribution of a certain province, and with the land use data in, for example, 2 years, we can get the land use changed areas in this 2 years using Symmetrize. With land use data and recovering forest distribution data, we can get the new land use data after recovering using Update. So as we talked about in the beginning, these are the different overlay analysis operations. So there is clip, there is erase, there is union, there is intersect, there is identity, XOR, and update. Now one thing to keep in mind about overlay analysis is that the source dataset must be a region dataset, and the overlay dataset can be any type except that in union and symmetrize operations, the overlay dataset must be a region dataset as well. So you should turn to the help document to see the diagram and explanation of each method. CLIP is a process of extracting feature parts from a source dataset, which is a CLIP dataset, using an overlay dataset, which is also a CLIP dataset. Now, for example, if you want to know about the land cover of a specified county, you can operate CLIP on the land cover dataset and the county dataset. In this example, we're going to get the land use data of Liuchuang village. So before we do any of the operations, what we want to do is that we want to look at the attributes of the polygon datasets that we are going to use in our operations. So let's go ahead and open up land use first. And now we're going to associate its attributes, and same for the Liuchuang village dataset. So we can take a look at these attributes, and once they have been done with the operations, we can look at the operation result and its attribute in order to compare them. We don't need to open any of the data sets included in this. We can go directly under spatial analysis and we can say overlay analysis. We're going to make sure that CLIP is selected, and in the input we're going to use the land use polygon, and in the overlay dataset we're going to use the Liuchuang village dataset. We're going to keep everything else as is, and we're going to say OK. So there we have our result, and in order to see the land use from the county, we're going to open our land use polygon, and we're going to drop our CLIP result on top of our land use polygon. So here we can see how much land is used by Liuchuang village. So that's how you operate the CLIP function. Now, in order to see the comparison of the result, what we have done is that we have opened the attribute tables of both our datasets, the CLIP result and the land use dataset as well. And now we will see how these interact. We have our CLIP result attributes on the left, and if we browse through them, we can see that they only let us browse through this CLIP result that we got from our CLIP operation. So we can see that it only goes through there. And as compared to this, the main land use dataset can go through both of them because it contains both attributes. So next up we have union. Now union is a function for performing the union operation on our source dataset and an overlay dataset. So let's go ahead and operate the union function in order to get the land use data with administrative information. Right, so for this operation we're going to be using two data sets again. One of them is going to be the same as the previous operation, and that is the land use data set. So let's open it up. And the second one is going to be administrative regions. So we're going to open this up as well. And we're going to browse each of their attributes so that we can get a general idea of what they contain. We want this because we want a comparison, and the end result is going to be where both of these attributes are going to be combined into one attribute table. So let's carry out the operation. So here we are again, and we're going to go under spatial analysis, overlay analysis, union, and in the input we're going to select the administrative regions dataset. Under overlay, we're going to leave it as land use. We're going to leave these as is, but we have an extra step here. We're going to set our fields. There's our field settings. And we're going to say select all and select all. And we're going to say OK. And we're going to say OK again. So there we have our union dataset where both of them have been combined. So in order to see the results here, we can browse the attributes of this, and we can see that they have been unionized. So our final demonstration here is going to be intersect. Now, intersect is a process of finding the intersection of a source dataset and an overlay dataset. After the exercise, we're going to open the attribute table to see the result as well, and we are going to compare the difference between union and intersect. So let's go ahead and do this. So again, we're going to go under spatial analysis, overlay analysis, intersect this time. Now our input data set is going to be land use, and our overlay data set is going to be Icheong Village. And we're going to leave everything as is, and we're going to set our fields. We're going to select all in source fields, and we're going to only select the last two in overlay dataset fields. We're going to say OK. We're going to check compare results. We're going to say OK as well. So there we have it. We can see it with a comparison, and we can browse the attributes there to see that they have all been intersected. So there we have it. So XOR, or symmetric difference. Now, XOR is a process of performing a negation operation on the intersects of a source dataset and an overlay dataset. Now, the example that you're going to do consists of a source dataset, which is land use of Beijing in 2000, overlay dataset, land use of Beijing in 2005, and the result is going to be land use change from 2000 to 2005. Our second last operation is identity, and this is a process of performing an intersect operation on a source dataset and an overlay dataset. So the example contains land use data of Beijing as source dataset, slope data of China as overlay dataset, and the result is going to be Beijing data with land use and slope information. So please go ahead and do this. So finally, we have update. Update is a process of replacing object parts in a source dataset with corresponding parts in an overlay dataset where the two datasets overlap. Now, the example that you're going to perform, farmland areas that need to be converted to forestry as overlay, and your result is going to be land use after conversion. So please go ahead and perform these operations and see how your results compare. So that's all for this tutorial on overlay and buffer analysis. Please practice the functions that we demonstrated in this tutorial so that you have a deeper understanding of them. Please consult the help document if you have any problems, or contact us directly. Thank you.